Hello, I'm recording this for the Machine Learning Foundation project for product managers. And I set up this project on Collab Research Google because it lets you use the setup without installing anything on your PC. And my PC is going through a bit of a turn, so I thought I could get this done here. I used the Python method, I did not use Excel or the other one. Here, I set it up here as I put the data that we got into the sample data, and I linked it here in the project as the file that we're going to use. It had 5 columns. So we've also set up linear regression and random forest as the two models that we're going to use later on here itself. Sort of that we've done a study of the data here, and we've seen in correlation that the atmospheric temperature is the one that has almost a very high correlation with the output. Here it's a minus, it's a negative, it's an inverse relationship of 0.948, which is only exceeded by the actual 1:1, which is sorry for the bad joke. So yeah, so and then we split the data. We have set aside a test data, and the rest of the data we use it to do a k-fold in 5 splits, and we shuffle it random state of 42, which sort of 42 of each kind. And so we have these many training rows. We have kept the test rows separate and the training rows. We then further divide into 4:1 to use it. To use both of them, linear regression, it assumes that there is a straight line relationship. In the correlation, we saw that the relationship was like almost straight. And then we'll try to do a random forest method, which captures the curves, and if there's a distinction or there are separate interactions right there. The result that we get is that the output metric, which was the first question, which I forgot to answer, was the root means squared error, which gives we get that as, for the linear regression we get it 4.5 megawatt, which is greater than 1% of the total number of the average um, uh, data of the average megawatt, that is I think 454, yeah, 454. So so for this we get the root mean squared error. We had to minimize this for a better model, and with the random forest one we get a 3.3, which is less than 1%. So that makes it the better model. It says that the relationship is not completely linear, it has a slight bend to it towards the top or the bottom, which also gives us a root squared of 0.96, which means that the 96% accuracy, only 4% of, which you'll see here, only 4% of these are not predicted by the model. Most of them are within 1% variation, which is great. Correlation between the real data between energy output and ambient temperature. These are the highest correlated ones. And this is my submission. I did this course around a year back, and I made this project now. I sort of skipped time in the middle. I'm sorry for the late submission, but it was a great course. Number one, I really like the LLM based question answer thing, and I really like making this project. This is my first time using Python, my first time using Collab. So I got to do all these new things. So thank you for the opportunity. And in case you have any more questions for me, I would be glad to answer. Thank you.